Hack the planet! Hack the planet!
We're in.
Shall we play a game?
How about global thermonuclear war?
Hey there, HackerFrogs. It's me, the Shy Hat, and we're doing Python coding today. So everybody, today we're going to be doing a coding stream. Oh, okay. Early morning. Hi, SysOS Master. Nice to see you here. And hope your sleep schedule is doing okay these days. So we're going to be doing 3 hours or so. Hat Night, hello, nice to see you here. We're going to be doing 3 hours or so of coding practice over here, over at LeetCode. And we're going to be coding in Python, which is, well, it's a pretty popular programming language. Today's the start of a new streaming week, and it's Sunday, August 9th. 8 p.m. over here, over where I am. Of course, it might be a different time where you are. So without further ado, let's put some time on the clock and we'll get started. So we'll start out by measuring out 2 hours, and we'll see where we're at after the end of 2 hours. Okay, you have a sleep schedule? What's this mythical thing? I also need to be careful about my sleep schedule because sometimes I have trouble. But yeah, hope you're having a decent time getting rest. So what are we doing today? We're going to be doing some LeetCoding. Where's my LeetCode window over here? So LeetCode has a section called LeetCode Quests. So it's basically a gamified version of LeetCode. Okay, pop quiz. What is the origin of Python language's name? So that's from Monty Python, which is a really popular comedy troupe in the UK. Or at least that's what I've been told. Okay, so we're working on these arrays over here. And if you want to do the same stuff we're doing, then you want to take a look over here. So we're doing part of the array section of these challenges over here. Did we finish this one? How many numbers are smaller than the current number? Let's see if how many numbers are smaller than the current number. I'm going to take a look. Oh, okay. Another thing we can do is we can put on a little bit of music while we're doing our streams. Let's go ahead and do that. If the music's too loud or too soft, let me know, and I'll try to adjust the volume. Okay, so we're doing we do keep write-ups for each one of our challenges over here, and this one's for LeetCode. Let's go ahead and do that. So LeetCode Quest, Data Systems and Algorithms, and Array 2. So this is, so we did question 1, set mismatch, and I guess now we're doing question 2, which is called, so Q2, what's this thing called? How many numbers are smaller than the current number? That's a bit of a mouthful, but sure. I'm pretty sure all the LeetCode Quest problems are also problems that are found in the main LeetCode site. It's just that they've adapted them for this course, or this game rather. So the reason why I'm adjusting the name of this question here is because GitHub doesn't like spaces in its file names, so that's why I'm doing my adjustments over here. So the URL where we can find this challenge will also record the concept we need to understand to finish this challenge, the instructions, and the method of solve, which is going to be like Python code. Toxy5e, hello, nice to see you here. Hope you're having a good day. Strap in, we're going to be doing some coding over here. So let's take a look at the problem. Okay, and we'll just read the question first. So given the array nums, for each nums element, find out how many numbers in the array are smaller than it. That is, for each nums I, you have to count the number of valid j's such that j is not equal to I, and num j's is less than nums I. Return the answer in an array. Okay. So alright, let's go ahead and copy all this, and then we'll put it in our instructions. So our instructions are over here. Great. And let me go ahead and get the URL for the challenge. Here we go. So the concept we have to understand is comparing elements in an array. And I guess in this case, the array is a list. Although I guess there is a separate array object in Python, but when they talk about arrays, they're basically talking about lists when we're dealing with Python. Anyways, let's go ahead and take a look at the problem. Where was it? Okay, so class solution def smaller numbers than current self nums list integer. Return a list which is an integer. Okay. Hat Knight says np.array I think is the only true array in Python. I think in most cases when they talk about arrays, when they're talking about Python, they're just talking about lists, because lists in Python basically take the place of what are called arrays in most other programming languages. But let's go ahead and get into our coding. So we're going to call this arrayComp.py. I'm going to paste in the code. So class solution so output a list. So self nums lists of integers, output a list of integers. Are you a programmer as a hobby or as a career? I'm not, well, I mean, I wouldn't call myself a programmer. I do cybersecurity stuff, and the reason why I do programming stuff as part of cybersecurity is because it's hard to get beyond a certain point in cybersecurity unless you understand a certain amount about programming. So the reason why I guess you could call it a hobby. I guess you could call it like supplemental learning for cybersecurity. Okay, so what have I been doing for the previous challenges? Let me just take a look at what I've got for some of my other solutions. Okay, so for the other solutions, I just create a solve object. So a solve object, and then I run the method. Okay, sure. So in this case, solve is solution, and we're running the smaller numbers than current. Okay, so we need to, before we go ahead and run that code, we're gonna have to write up this function definition over here. And you know what? Just because I don't really like the what is it called? The 4 space indentation, I'll do a 2 space indentation. Okay, so it takes in a list, and it outputs a list. Smaller numbers than current. So let's think about what the program has to do. This program has to take in a certain object or element of an array of a list, in this case. Take in a certain element of a list and return the number of elements in that list which are less than the current, well, the target element's value. Footlong Icicle, hello, nice to see you here. How are you doing? You're a pretty frequent viewer over at Slyborg's channel. Have you heard much from Slyborg lately? The last time I heard, she was designing like some stickers or something. She was designing stickers for something she wanted to do for DEF CON, right? And I'm not too sure how her DEF CON went. I guess I'll have to ask her the next time I see her. Online, that is. Okay, so let's see. Smaller numbers than current, self, nums, list, integer, output, list, integer. The number of elements in that list which are less than the target element's value. So I guess one way we could do this is we could do target equals nums. Wait, what are we taking in again? Okay, so input nums 81223. Output is 40113. Oh, okay. I think I understand. So for each element, we have to return the number of elements that are smaller than it. So in this case, there's 8, and there's 1, 2, 3, 4 elements that are smaller than it. Yeah, okay. All right, let's get to work then. So I guess smaller equals 0, and then we can run like a for loop for I in nums. So we take in nums as a parameter. So for I in nums, I guess we need to... For I in nums, maybe we need to take in two elements. So I and j in nums, because we're doing like a loop inside of a loop. But if we're doing a loop inside of a loop, then we can do something like for I in nums, for j in nums, and we do if I is greater than j, then we add one to smaller. So if I smaller plus equals 1, or plus equals, yeah, I think this is the syntax, right? So smaller plus equals 1, and then that'll run through everything, every element in the list again. So I guess smaller also, why 2 loops? So the first one iterates over all of the elements of the list, and then the second one also iterates through all the elements in the list, because we need to iterate through the elements in the list to figure out which elements in the list are smaller than our current element. I mean, you do have to, well, you don't necessarily have to do it in 2 loops, but I think this is the easiest way for me to understand it. So I guess we can make another list called results, and we'll just append smaller to results at the end of this loop here, the inner loop. So smaller, so results dot append smaller. Okay, and I guess we can also create a sample list. Sample list equals, okay, so as asked, would we not need an array as a return value? Yeah, the array is the return value, right? So we define it over here, and hopefully we can return it at the very end of the function here. So return the results. So we'll make a sample list. We'll just make it equal to the example over here. So 8, 1, 2, 2, 3. Reset smaller at the point after the append or at the beginning of the loop I. Shubha Deep Swain, hello, nice to see you here. You need some advice? Yeah, no worries. Go ahead and ask. If I can give you advice, I'll give it. So sample list is here. So we do need to reset smaller after each one of these. So for I and nums, for j and nums, smaller append 1. And then we reset whoops, we'll reset it at the end of this one. So append the results and then reset the smaller variable. Oh, is my indentation correct? I don't think it is. Hold on. 1, 2, 1, 2, 1, 2. Okay, that looks okay. Jackson America, hello, nice to see you here. What is up? Hope you're having a good day. Okay, so we'll save this out. We'll see what happens when we try running this. Print. Okay, so it's called sample set, sample list. Okay, so I'm working, so Sheba Deep Swain says, I'm working in MNC in India. My designation is Associate Infrastructure Engineer, but to be honest, it's just monitoring stuff being done on a SaaS product and I'm learning nothing. Okay, I mean, if you're working at a job, if you're working at a tech job and you feel like you're not really learning anything at the job, can you do training to get something to move into a job that would be better suited to you, right? So let's talk about this a sec. So Shub Deep Swain, working at a tech job, feels like they're not learning at their job. So in this case, my advice would be to do training for a job they're interested in while staying at their current job. So after enough training for another job, start looking for for postings in that job, but don't quit your current job until you get hired for another one. Okay, Jackson America asks, do you have any experience in C++ programming language? I mean, I have some experience using C, and I'm taking a C programming course right now. C++ is just kind of C with extra stuff on top, right? But I wouldn't say I'm very good. I wouldn't say I'm good at C++. No. Okay, Jackson America says, my father just gave me a new laptop. Okay, that sounds good. Finally, I got freedom from my 13-year-old laptop. Hat Knight says, industries across the globe are magnifying domain knowledge as a primary qualifier. Technical skills are demonstrated as supplemental. Trade up for a role in a similar domain. Mako Monotsukuri. Hello, nice to see you here. Different type role. Okay, so Shaba Deep Swain says, should I start from zero to learn how to code, or should I start from zero to learn how to code, or should I learn and improve on cloud or DevOps to build on my resume? Because if I switch to SDE, my past experience won't count. Well, I mean, I'm not really too sure whether or not you can transfer any of your current skills into a new one. You'd have to do that research yourself. But I'd say that, you know, if you want to do something completely different, you need to ask yourself, are you willing to put in the time to do the training to do that job that's very unrelated to what you're currently doing? And think about whether or not it's worth it. Mako says, using Nano like a king or queen. I mean, I just use Nano because it's the easiest thing for me to use. I'm not really used to using IDEs, so that's why I use Nano. Okay, so we'll run the code in here. Python, what's it called? Array comp. Okay, so what do we get? 04221. And I'm pretty sure this is not what Okay, there's one thing. 1, 2, 3, 4, 5. So there's 0 that are smaller. Oh, did I get my greater than and less than mixed up again? So if I greater than J, if I greater than J is what we're looking for. Okay, Jackson America says, these days I'm trying to learn C plus some C programming language, C++ and some programming language. I'm confusing which is the best for me, JetBrains, Cleon, or Microsoft Visual Code. I mean, use whatever IDE helps you the best, I'd say. I don't really have too much experience with IDEs, unfortunately. Okay, everything is limited, like I do not get to work on the Polar server because they don't give me access to, so I have to depend on the backend team or the SaaS product. I'm afraid I'm not too knowledgeable about that stuff. Grey Wolf Medi, hello, nice to see you here. Okay, so SysOS has a suggestion. He suggests JetBrains. Or does he actually suggest JetBrains? Okay, so we've got our code over here. Let's run it again. So we got 40113. 40113. I'm pretty sure that's identical to the results we want, right? So 40113, and then we'll do 6543 as the next example, and we should get 2103 as our result over here. Let's go ahead and try that out. $2103. Yeah, okay. And then we've got 7777, which should result in all zeros. That was a lot easier than I thought it would be. I thought it would have big trouble. Okay, so I think this code works, so we can use this as the solution. Okay, so let's catch up with chat. Jackson America says, I do not have experience in JetBrains IDE to learn C++ and C. Okay. Shiba Duke Swain says, to be honest, I have left DSA at strings and recursion 2 or 3 times in the past 3 years. It's just I can't stay consistent and I forget them. I tend to learn some new language and the loop continues. No stronghold. Well, I mean, I think what you need to do is you need to lock in and you need to do some stay consistent. It's hard to stay consistent if you're learning something that is not super interesting to you. My advice to you for that would be to be interested in the stuff you're learning. And if you're learning stuff that's not interesting to you, you need to ask yourself why you're not interested in it. I mean, the reason why I can do Python coding challenges like this is because I actually think I'm very interested in Python, and I think that it's really fun to be able to get the programming language to do what you want it to do. Anyways, we've got a break on Twitch right now, so I'm just going to take this opportunity to put on some birds. How about these birds? Okay, we'll be back in about 30 seconds. I just need to take a little water break. But enjoy the birds and the music. Okay, so I think let's go ahead and submit our first submit our first set of code. Alright, so over here, we'll just paste in our code. I think we need to... Okay, so I think this is correct indentation. All right, let's go ahead and submit this, or we'll run it first. Wrong answer. What happened? Looks like... What happened in here? Okay, so results equals this, smaller equals this. For I in nums, for j in nums, if I is greater than j, smaller... Oh, okay. I forgot to indent this. Okay, and we'll try it again. What happened here? So there should be the reset. Okay, the reset is in the wrong place. Where did I put it again? So let's see, for j and so results at append smaller, then smaller equals 0. So this is inside the for I loop. So for I, okay. So return results is in here. I think it should be okay now. Okay, when is it reset is in which loop? Yeah, I was just trying to correct that. Cold Win Who says, I'm not gonna lie, I'm so lazy when it comes to learning C++ assembly and Linux for exploit deployment, or exploit development. I mean, it's kind of fundamental. It's kind of fundamental to learn about C and assembly language if you want to do those, write those exploits. So it's kind of completely necessary to do that. Wrong answer again. Hold on. Let's make this a bit smaller. And let's compare what we have. So for I in nums, for j in nums, if I is greater than j, smaller... Oh, okay, I think I've got, it's on the wrong level. So for j and nums and results in smaller have to be on the same level. So this goes here. Alright. Cold Winu says, I just want to be a cracked exploit dev and researcher and find crazy CVEs in popular apps. And you're right, it is fundamental, albeit I'm lazy. I'm too lazy to sit down to grind and learn. If you're... then you don't want to be a cracked exploit dev. I mean, what's the, what are we talking about? So So cold win who? I want to be a expert exploit developer. I don't want to learn C or assembly. So doesn't that mean I don't want to be an expert exploit developer? You can't be a thing without learning to be the thing. I mean, if you're not motivated to learn the skills you need to learn, you know, to learn to be the thing you want to be, then you don't want to be that thing. I mean, okay, let's suppose my goal. I want to be a doctor. I don't want to learn biology. I don't want to go to classes. These do not mix. So the difference between the person who's a doctor and the person who's not a doctor is that they learned biology and they went to their classes. Amen. Hello, nice to see you here. I mean, I think you need to think, if you really want to be an expert exploit developer, you need to ask yourself, do you really want to learn C or assembly and all that stuff? Because if you don't, maybe you need to reassess this goal right here. Why not become a doctor of philosophy? I don't know. I mean, you can do stuff in cybersecurity that doesn't involve learning C or assembly. They're just different roles. They're not exploit developers. So if you wanted to do, like, you know, web app security testing, or like network security testing, or if you wanted to do digital forensics, you don't necessarily need to learn C or assembly. They do not need to learn biology. Do doctors not need to learn biology to do their doctor classes? Professionals practice their craft. Yeah, that's true. And Randolph, nice to see you here. Okay, so let's see if this code works now. Okay, Colwinu says, I just want to find and write exploits for RCEs, LPEs, and stuff. I mean, what are you going to be using to write the exploits? I mean, I guess you could. I mean, if you wanted to shortcut learning C or assembly, you could get AI to code all the exploits for you. But in that case, who is the exploit developer? You or the AI? Not to say that you can't have AI help you out with some parts of the code, but you need to know C and you need to know assembly if you're going to be writing these exploits. Okay, so it worked. Did it work? Looks like it worked. Okay, we got our indentation problem solved. All right, we'll try submitting the solution. Eamon says the AI won't even give you the solution. I mean, I'd say, Coldwin, I think the first thing you want to do, if you want to learn about exploit development, try Pwn College first. So Pwn College has a bunch of courses on stuff like software security flaws and reverse engineering. It's a good first start. It's a good first couple of steps, right? So go over there, take the take the software security courses, take the reverse engineering courses, teach yourself some C. Learn to you need to learn to like learning C. If C is your first programming language, it might not be your first programming language. You probably know other programming languages beforehand, right? Could you tell me which other programming languages you program in right now? Random Stokes says it doesn't matter if AI gives you an exploit if you don't know how to use it or how it works. I mean, that's the other thing, right? You can learn C fast in CS50. Yeah, I mean, I'm also working through a C course right now over at EduB. Let me see if I can pull it up. So there's a bunch of good resources for learning C. I mean, the thing about learning C is that when you learn how to code in C, you can create binaries that you can hack. Once you learn what the insecure functions are, you can start creating your own binaries that you can hack, and you can learn from that. Okay, so I'll give you the link for this course. So in addition to this course, there's also Exorcism, which is really good. Exorcism.org. And they've got a bunch of C programming resources over there as well. Okay, so did we beats 38.87%? Okay, so it's not very fast, but I'll call this a win. Okay, Eamon says, by the way, CS50 is the best of all. It's free. It's a course for normal developers, not exploit developers. I mean, a course for normal developers is also beneficial for people who want to write exploits. But yeah, if you don't have the fundamentals, you can't realistically learn how to write exploits if you don't know the programming languages that you need to write them in. Okay, so let's go ahead and finish off that write-up. Where is it? Okay, here's our solution. But I mean, it's tough. It's tough to be motivated. It's easy to get distracted. It's easy to not work on the stuff you're supposed to, right? I understand. It's very easy to. You have to love what you're learning. Otherwise, you're not going to be motivated to learn it. Okay, let's go ahead and move on to the next challenge. Next question. Subscribe to Unlock. Thanks for using LeetCode. To view this question, you must subscribe to Premium. I guess I'm not doing this question then. Huh. For all of these, you need to be subscribed to Premium, huh? Well. The best time to be a machine is late night. Okay, so we did this problem. I just want to make sure that we're actually being paywalled here. So this is the smaller than current number question. And then, okay, we need to subscribe to unlock this. Just go next, it will eventually give you a free one. Thanks for the advice. Let's give it a shot. Subscribe. Oh, okay. So this one is not. Hold on, let's reload the page. Also, cybersecurity is the Olympics of IT. It's not for everybody, and that's not a shame. I mean, cybersecurity isn't for... No available editorial for now, we're working on it. Cybersecurity isn't for everybody. It's for a certain number of insane individuals. Are you the descriptor tab or the editorial tab? It's a good question. Description tab. Okay. Okay. So, right. Thanks for the advice, Hat Knight. So we'll go back, set mismatch, find all. Oh, that's why I wasn't able to see it, because I'm not able to find the editorial. Okay, so we actually can do this question. Okay, so this is... You need the premium for the editorial, but not the description. Yeah, thanks for letting me know. Question 3. Find all numbers disappeared in an array. Given an array nums of n integers where nums I is in the range 1 is in the range 1 n, so it starts at 1, stops at n. Return an array of all integers in the range 1 n that do not appear in nums. Oh, okay. Send the link so I can do it with you? Yeah, sure. Sure. This should be the link here. But I think this is also like a regular LeetCode problem as well. Let me see if I can find it. Yeah, find all numbers disappeared in an array. So each one of these LeetCode quest problems is a regular numbered problem. Okay, for example, if you got these numbers, we need to figure out that there's 5 and 6 missing from this array. And whoa, what is this? 1 to 1? Output is 2. Why is the output 2 in this case? So here it makes sense because it's the numbers start at 1 and they end at 8. And we see that there's no 5 or 6. But in the second example, the numbers start at 1 and end at 1, but for some reason, we're supposed to output the number 2. So that doesn't really make too much sense to me. Given an array of nums of n integers, where nums is in the range 1 to n, return an array of all the integers in the range that do not appear in nums. Oh, okay, okay. So it's because there should be a number 2 in here. Since it's a 2-element array, there should be a 1 and there should be a 2. And in this case, it's a 3, 4, 5, 6, 7. It's an 8-element array, which means that there should be the numbers 1 to 8. And in this case, it's missing a 5 and a 6. Okay. Yeah, it's making more sense to me now. So starting from 1 going up until the biggest number. Yeah, so the range of numbers is 1 to n, where n is also the size of the array. Yeah, that makes sense. Okay, follow up, could you do it with an extra space in the runtime? You may assume that the returned list does not count as extra space. The other question here is like, are we expected to write code that includes the follow-up? Okay, let's just copy our instructions here. Actually, first, we'll make this file in our walkthroughs, because we're trying to record all this stuff. Two Facho, hello, nice to see you here. Hope you're having a good day. So the range of numbers is 1 to n, where n is also the size of the array. Yeah, I already read that. Okay, so let's go ahead and set up our walkthrough. So we need to record the URL of the challenge, the concept, we need to understand the challenge, and the instructions, and the method of solve. Okay, so for this one, let me grab that URL. Okay, Randolph says that the extra is asking for the assignment to be done without using a separate array and going through the original array once. Going through the original array once. I mean, that sounds like a bonus assignment. So the concept in this one is identifying missing elements in an array, or a list, I guess, because we're talking about Python here. Let's grab the instructions. And copy them over. And then let's get to solving this. Where's our code? Okay, so let's see. Class solution, find disappeared numbers. So we can actually edit the code we had here earlier. But we're running a different function here. Find disappeared numbers sample list. I guess we can also define a sample list up here. So what's our first sample list? This one. Okay, so let's talk about what this program is supposed to do. This program takes in an array, which starts at 1. Well, okay, an integer array, I guess, or an integer list. At 1 and ends at n, where n is the largest integer in the array and is also the stopping point. Program must output any numbers missing from the array in the form, or from the list in the form of a list. Okay, Cypher, hello, nice to see you here. Hope you're having a good day. We're just doing a little bit of LeetCoding over here. If you want to see which problem we're doing, it's this one over here. And this is part of the LeetCode Quest series of challenges. Okay, so how do we do this? You know, just because I don't want to fight with the code editor later, I'll keep everything as four spaces. So I guess what we need to do is we need to count the number of elements in the list. So in this case, element sum. I guess that's a bit verbose. We'll just call it the eSum. The element sum is going to be the sum, not the sum, the number of elements in the list. There's a function for that, right? So list get number of elements. There's got to be like an easy Python function for that. List function, or list, maybe it's called like count of. Could create an array of size n whose values are n. Read in the number, or length, right, the length function. Just run the length function. So eSum equals length of nums, right? Randolph says, could create an array of size n whose values are n. Read in each number from the original array and remove the value from the new array. And remove the value from the new array. The new array will be left with the missing numbers only. The new array will be left with the missing numbers only. I mean, I guess yeah, I guess we could make like an expected list. So expected list is going to be, oh, this isn't very, is this the Python method of naming integers? I'm not even sure. So expected list is going to be, we'll just call it like an empty list first. Or maybe, so we'll just make it an empty list first and then we'll populate it by running like for loop. So for I in range, and I guess we can comment this as well, like populate the expected list. So for I in range, exp list I in range start at 1 and stop at eSum, which is the length of numbers. Python is snake case. Snake case? This is snake case, right? Like an example, this is snake case. That's the expected variable naming system in Python, right? I could be wrong. Okay, so for I in range, start at 1, end at eSum, exp lists, expected list dot, okay. So if it's supposed to be snake case, then we need to, we don't need to, but I guess we could just do it like this. And like exp sum, it is a bit more verbose though. Expected sum, expected list. append I. And let's just see if this part works. So after this, we'll just print it out. So print exp list. Okay. And we'll run it. But this is named the wrong thing now. So we'll write out to disappear num. Okay. Hyper Resi. Hello, nice to see you. How are you here? Are you a frog man? I'm actually a hat man, but I'm on top of a frog, is what we're supposed to be. Okay, we'll run the Python script, disappear unexpected indent. So this is line 14. No. Where's my unexpected indent? Oh, this one. Okay. Sorry, you gotta make sure everything's lined up correctly in Python. You're sitting on a frog? I'm a hat. So I'm on top of a frog, yeah. Solve.find. Ooh. Print solve.find. Where'd that come from? Yeah. Oh, okay. All right. Let's run it. So 1, 2, 3, 4, 5, 6, 7, none. Where did the none come from? Because we're only printing one thing. So we did populate the list properly, did we? There should be 8 though. 1, 2, 3, 4, 5, 6, 7, 8. So it should be 1 to 8. So I guess we need to do expected sum plus 1. She came from the church. The church? Which church are we talking about? Okay, now we've got the correct number of elements. So 1, 2, 3, 4, 5, 6, 7, 8. And whose suggestion was it? So Randolph said that we should pop out the number. And then after we're printing the return to. The return to. Okay, so now that we know that this works, we can work on popping out. So remove this element from the list, right? Populate the expected list and then depopulate. And then depopulate the expected list. So populate the expected list and then depopulate it. From the list elements. So this is another for loop. So for I in nums. Now, what was that command? Expected list. Read in a value from the sample list and remove the value from the expected list. Yeah, this is what we're trying to do right now. Okay, so Python delete elements from list. There's like 3 different methods, I think. So to delete by value, so use the remove method. When you know the exact value of the item you want to delete, Note that this only deletes the first occurrence of that value. Okay, it raises a value error if the item does not exist. So we can't use this method because it errors out if it doesn't exist. Delete by index, so pop. Use the pop method when you want to remove an item in a specific position and retrieve its value. So I don't think we want to do this either. Okay, and delete by value remove. Use the remove method when you know the exact. BlazeBits is raiding in with the party of 35. Hello, raiders. Happy birthday. Well, thank you. Thank you for the happy birthdays, Agent 57. Mr. Poolshot, hello, raiders. Wow. Let's give a shout out to BlazeBits, who is a cybersecurity live streamer who talks about cybersecurity news. Hack the planet. Hack the planet. Thank you. But yeah, we're doing some LeetCode right now. So we're doing this problem over here where we need to do stuff with arrays, do stuff with lists and stuff like that. Lots of fun. But yeah, welcome in, raiders. My name's the Shy Hat. I do cybersecurity content on Twitch and on YouTube, and I also do like general tech content as well. And I guess this is what I'm doing right now. We're doing some coding. We're trying to figure out how to do these LeetCode problems in Python. I don't care what others say. I like Python. Okay, you'd have to remove the value from the expected lists as each value is read in, and shrink the length of the expected list if the value is removed. So, yeah. So in the current problem, we need to figure out which numbers in a list are missing. So if you give us a sample list over here that has the numbers 1 to 8, and it's got 8 elements, we need to figure out that the numbers 5 and 6 are missing from these numbers. Thank you very much for following Mars06. Thank you. But yeah, how do we remove every instance of something? So delete every instance of element from list. Let's see, list comprehension. So let's see. This approach filters out unwanted elements and creates a brand new list. It is fast, clean, and handles multiple occurrences instantly. So the original list is x for x in my list if x is not equal to 2. And the output from my list is now 1, 3, 4, 5. That removes all the 2s. Atval, hello, nice to see you here. Shout out, please. Yeah, we shouted out BlazeBits. Didn't we shout out BlazeBits? I'm pretty sure we did. Let's see if we can give him another shout out. There you go. Oh, I need to wait 2 minutes before I can shout you out again. But Atval, hello, nice to see you. Hope you're having a good one. And thank you very much for following on Twitch, Mars06. Thank you. But yeah, BlazeBits, do you ever do LeetCode stuff? Or like, you know, set would be easier? Is it my birthday? I think it's my birthday every time Agent 57 comes in here. In-place modification, slice assignment. If your code requires you to modify the exact same list object in memory, mutating it in place using slice assignment along with list comprehension. So modifies the existing list object in place. But I mean, we still get... So my list, something something. X for X in my list if X is not equal to 2. I mean, we're doing this for every... We're doing this as as a for loop. Let's give this a try. Not good enough for LeetCode, barely cool enough to stream my silly hacker shenanigans. You know, this is a pretty big debate in cybersecurity. Like, how much coding do you need to know to do different roles in cybersecurity, right? So, do I need to code to do cybersecurity? So, I mean, the answer here is it depends. It depends on the role. So, some roles require way more coding than others. Most roles will be easier if you know a scripting language at least. That is, like, you know, Python basics is a bare minimum for most of your cybersecurity roles. But I guess, you know, some other roles, some specialized roles require a lot of coding knowledge. So that would be your, you know, reverse engineerings, or your reverse engineers slash, like, malware analysts. Ooh. Reverse engineers, malware analysts, and also, like, the opposite, which is your exploit developers. And malware researchers. So there are some roles where you're not going to be doing very much coding at all. So I'd say that the roles with the least amount of coding would be something like your SOC analysts, maybe your digital forensics analysts. You know, maybe even something like a network pen tester doesn't have to know so much doesn't have to know as much in as far as, like, programming is concerned, because they're mostly running tools. But then again, you know, those are those can be fighting words depending on who you're talking to. Okay, so Blazebit says we do like a whole year of coding working on a hack bot in a language chain, but even then I feel like it couldn't do these challenges. I mean, they're geared towards different kind of things. Doing, like, data structures and algorithms is not exactly the same as scripting up a bot that's gonna interact with, like, a network service. But, you know, it is kind of fun to figure out how to solve these challenges. But Blazebits, if you have, like, a different opinion, please let us know, because I'd love to hear your opinion, because you've been working in the industry for a long time. Okay, so what were we doing? We're trying to figure out how to depopulate this list. Modify the existing list object in place, sure. My buddy can't see the chat in the DuckDuckGo browser. I'm afraid I can't help you. I can't help you with your browser problems. Okay, what are we doing? So for I and nums, so my list, I guess this would be the expected list. List comprehension. So X for X, I guess it would be J for J in my list if X is not equal to element I in this case. And at the end of that, we'll print out the expected list. Blazebit says he needs to use Goose Goose Honk. It's a far superior browser. Okay, so Atvo asks, do you know about randomized generated MAC addresses for privacy? Randomized generated MAC addresses for privacy. I mean, where did you hear about that, Atvo? Is Ivanov says, can you do if next number is not equal to current number plus 1, insert in the list? Sorry, did not see the problem at hand clearly. Instead of x is not equal to 2, check if x is in the set. Okay. Change the x to j. Change the x to j. Oh, right. Yeah. So if j is not equal. I mean, we could do this one of two ways, because what we're trying to do here is we're trying to discover missing numbers. So if we've got a list of 8 elements from 1 to 8, we need to find, our program needs to find the missing elements 5 and 6 from this list. And you could do it one of two ways. You could subtract from a list of expected values, or you could also check against expected values in like a for loop. Anarchist says random MACs are useful for phones where you talk to random Wi-Fi networks, not so useful for desktops. Okay, so let's see if this code works. Okay, just run it. Inconsistent use of tabs and spaces. Oh, can't use tabs and spaces. No? Where did I mix up my tabs and spaces? This is line 19. 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2, 3, 4, 5, 6, 7, 8, 9. It was in here? Oh, okay, it was in here. Okay. Okay, A says, expected list is set of expected lists, then check that X is not in the expected list. Yeah, I mean, that's another way we could do it. But A97, hello, nice to see ya. Welcome to the stream. My list. We're not using my list. We need to use expected. Okay. This is what happens when you copy paste stuff from the internet. 5, 6, none. Okay, so this seems to work. There's device shops that can buy that sniff the MAC of phones to identify customers. Not really sure the idea really took off though. The other thing we need to consider is like speed. Sometimes speed matters in these challenges. I'm not too sure if this is one of those challenges. So it seems to be working in this case. So in this case, we just return the expected list. So that brings up 5, 6. Okay, we'll try it with the other inputs. Vibe scripting, yeah. Okay, not sure being able to use tabs for space, not being able to use tabs for space. Well, I mean, you need to do it consistently. That's what Python complains about. You can use either tabs or spaces. Okay, done instead of print, make it return the list. Yeah. What's the next one? So the next example is 1, 1. Okay, let's plug that in, and it should return that it expected 2. 2. Okay, good. It seems to be, the sample seems to be working. So we'll just copy all this code. and we'll put it into the code editor here. Okay, we'll run it. Eamon says, by the way, it's my solution. Hope you like it. Oh, thanks. Yeah, I mean, it seems to be working. And let's submit this. Hopefully, it doesn't time out. Okay, Eva says, on phone with the browser, my buddy can't see the chat. I mean, I don't think... Ooh, yeah, we exceeded the time limit here. So we need to find a faster way to do this. Python complains it doesn't work properly because it's terrible. Cypher, yeah. Well, I mean, we need to... I'm just trying to get better at coding in Python. That's why I need to use the Python. So 30 out of 35 test cases passed. Okay, so we need to find some way to speed this up. Let's go back in. So populate the expected list and depopulate the list from the list elements. I think... I mean, either way, because we're running for loops, if the arrays are really big, we could run into timing issues. So how do we get around this? So Eamon says s nums equals set of nums return for I in range 1 length nums plus 1, if not Python is the birds, the one in the segue. Drop some random semicolons in some C code and C will complain. Are birds even real? That's a good question. So we need to find some way to make this code faster. So I guess we could use the set of nums to populate instead. So expected list equals set nums, and that might make it a little bit faster. We'll comment this out. Okay, it's wrench. Who is wrench? Who is wrench? The problem is the second loop. Yeah, the second loop is a bit... Oh, what happened here? Set object does not support item assignment. Okay, so we can't... So this isn't... The set object is not a list. And what did... So Eamon was talking about his code. So set of nums and return I for I in range 1 length of numbers. Okay, let me take a look at your code. So return I in range 1 length of numbers, if not in snums. So snums is expected list in my code. EXP list. Gotta change the comprehension. Errors on line 25 and 19. You know what? You know what we should do? We should use our line numbering when we run nano. So I think it's -L. Yeah, okay. So now we've got lines. Hold on, I have to cough. Do you want me to simplify it? Oh, I'm not looking at the right one. We should be looking at disappeared numbers. We already had lines there. Now they're numbered though. Well, I mean, that's true. That's true. We want the numbers with the lines. Okay, so does this work? What's going on? Wrench, hello, nice to see you here. We're just running, we're just trying to solve some LeetCode problems. LeetCode challenge, hacker doing LeetCode. Well, I mean, we're just trying to get better at coding. In this case, we're trying to get better at coding faster, because our problem is that we're not going fast enough. Okay, let's go ahead and paste in our new code. Let's get rid of all this commented out stuff. Okay, and we'll run the test stuff. Test stuff comes back okay. And then that worked, change the data set up. Yep, and we'll see if it passes the cloud tests. Okay, this is way faster. What about a sub that isn't cut all the way through? What are we talking about? Are we talking about submarine sandwiches? Oh, we're talking about submarine sandwiches. A sandwich consists of 2 slices of bread, a hot dog. Like many sausages, goes in the bun, not between 2 slices of bread. Okay, Eamon says you can check. This is it's simpler list. Comprehension is kind of hard. List comprehend. I mean, I never really got the list comprehension syntax very well, but I do need to practice because list comprehension comes in very handy sometimes. Okay, let me fix up the comments in here. So expected list is the length of numbers. I mean, this is kind of redundant here. So expected sum, because we're not really using that. We only need these 2. Oh, okay. Anyways, disappeared numbers, this code here, we will copy it over. And we'll include it in our write-up. Then we'll move on to the next question. All right. Commit these changes. And we'll move on to the next challenge. So description, set mismatch. Wait, this is the first one? Question 3, question 1, question 2, question 3. Okay, so we're finished this section. All right, we can move on to the next section. Okay, now we're doing the stack. Stack? Oh no, we're doing C code again. Okay, let's take a look. Carry on, gentlefolk. I have to work in a few hours. No worries, Randolph. Hope you have a good day. And hope to see you again. A rhino is also a unicorn. It sounds like we're playing around with some programming problems. Okay, so so Q1, build an array with stack operations. Stack operations. Pale Horse 99999 is followed on Twitch. Thank you. So you're given an integer array, target, and an integer n. You have an empty stack with two following operations. Push pushes an integer onto the top of the stack. Pop removes the integer on the top of the stack. You also have a stream of the integers in the range 1 to n. Use the two stack operations to make the numbers in the stack from the bottom of the stack equal to target. You should follow the following rules. So if the stream of the integers is not empty, pick the next integer from the stream and push it onto the top of the stack. If the stack is not empty, pop the integer at the top of the stack. If at any moment the elements in the stack from the bottom to the top are equal to target, do not read new integers from the stream and do not do more operations on the stack. Advow says, in our country we have to fill out a census, otherwise a $380 fine daily until it's done. How often do you have to fill out the census, Advow? Return the stack operations needed to build target following the mentioned rules. If there are multiple valid answers, return any of them, so just return one of them. So what is actually going on here? So target equals 1, 3, n equals 3. So we're talking about an array which has like 1, 2, and 3. So 1, 2, and 3, and our target is 3. The output is push, push, pop, push. Initially the stack S is empty. The last element is the top of the stack. Read 1 from the stream and push it to the stack. S equals 1. Read 2 from the stream and push it to the stack. S equals 1 and 2. Pop the integer on the top of the stack. S equals 1. Read 3 from the stream and push it to the stack. Oh, okay. So the target is the numbers 1 and the numbers 3. Okay. Adva says every 4 years. Every 4 years, they send it to every household. They ask for, like gender stuff? I mean, in most countries you're supposed to fill out your census information, otherwise people get mad at you. Okay, so target 1, 2, 3, n equals 3. N equals 3. So what's the n value again? Output is push, push, push. So S is empty, then push 1, then push 2, then push 3. Target is 1 and 4. 1, 2, n equals 4. N equals 4. Push, push. Initially the stack S is empty. The last element is the top of the stack. Read 1 and then push. So first element and then second element. Since the stack is equal to the target, we stop the stack operations. The answers that read integer 3 from the stream are not accepted. Okay, so it seems like this could become a pretty complicated program. All right, let's start by starting up our write-up. So this is datasets and algorithms. So this is array 1, array 2. I should probably name these as well. So how do we rename this? Does anybody know really quickly how we can rename our directories in GitHub? It's okay, I'll do it later. Okay, so the new file is going to be, we'll just call it like 03 stack. And this is going to be question 1. Build an array with stack something something. Okay, we'll record the URL where you can find this thing. The concept we need to understand to do this, the instructions, and the method of solve, which in our case is good old Python. Just rename it in your computer, then commit and push. I'll do it after the stream is over. But thanks for the advice, Eamon. Okay, so the concept in here is build a specific list. Specific list with memory stack like operations. Okay, so we copy over the instructions and then we can get started. So we'll call this, actually we'll just use the previous code, but we'll rename it. So we'll call this new file stack operations.py. This is a different program, and we need to copy this over. So what's the function supposed to be called? Build array. Build array. Okay. Okay, so we take in a list with an integer and then an n value, which is also an integer, and we output a list. We output a list with a string. Output a list with a string. Okay, so we'll do sample list, and we'll also do sample n. What are our examples over here? So target 1, 3, and n equals 3. I'll send the solution when you get stuck. Gotta check, gotta stuck, check, gotta go to now. Gotta go for now. No worries, Eamon. Just trying to understand what's going on. But yeah, you just need to defang the link. But you can send links in YouTube as long as you defang them. So basically get rid of all the dots. Ah, okay. Alright, well, I'll put it somewhere. Actually, we'll just call this like Amen. Amen.py. And I'll take a look at it if I get stuck. Thank you very much, Eamon. Okay, so what is this program supposed to do? Let's take a look at the instructions one more time. Okay, you're given an integer array, target, and an integer n. You have an empty stack with the two following operations. Push pushes an integer to the top of the stack. Pop removes an integer on the top of the stack. You also have a stream of the integers in the range 1 to n. So the stream of the integers from 1 to n is n indicates the largest number in the range, right? In the stream. Use the two stack operations and make the numbers in the stack from the bottom to the top equal to target. You should follow the following rules. If the stream of the integers is not empty, pick the next integer from the stream and push it to the top of the stack. If the stack is not empty, pop the integer at the top of the stack. If at any moment the elements in the stack from the bottom to top are equal, do not read new integers from the stream and do not do more operations on the stack. Return the stack operations needed to build target following the mentioned rules. If there are multiple valid answers, return any of them. Okay, so the output is going to be... so we need to return these instructions. So push, push, pop, push, in this case. Okay, so we should probably start with this one over here. So 1, 3, and then aim equals 3. Yeah, so this one here. So I don't quite understand what's really going on here, but I guess I'll have to muddle through it to finish. So we are given a target list which has the numbers we want to, the numbers and positions we want to create. So in this case it would be a list with the number 1 and 3. We are also given a number which is the largest number in a list of integers that we can... Okay, bro, do you use NeoVim? I mean, I'm using Nano right now, so I'm not using NeoVim. The next big thing, hello, nice to see you here. How are you doing? If yes, how do you configure it to work with Java? I'm sure somebody in here uses NeoVim because it's a pretty popular text editor. So if you know how to get NeoVim to work with Java, please let the next big thing know. Thank you. Okay, so we're also given a number, which is the largest number in a list of integers that we can populate the quote-unquote stack with. we have two operations. We can do to our list. We've got push which appends to the end of the list the number the current number in the what would we call this thing? So this n and this number, the current number in the queue. I don't even know if that's correct. Cypher says ban Vim, ban Python. I think it's called a stream. Oh yeah, okay. It's a stream. Zamru, nice to see you here. In the stream. A number which is the largest number in the list of integers that we can populate the stack with, called the stream. So the push operation appends to the end of the list the current number in the stream. And then there's the pop operation, which removes the last element in the list. Listen. People, Cypher's he's just joking mostly. You don't need to ban him. You don't need to time him out either. Okay, so we need to record which operations we did. So the operations are push and pop. To arrive at our solution. And return it at the end of the program. Okay, so we've got our sample list, we've got our sample n, and I guess we can start creating our functions over here. So the list is the target. The list is the target, the n is the maximum number in the stream. And we need to output a list which is a string. So I guess the string would be, I don't know, we can just call it the target string. And the target string is a list. The target string is a list with a bunch of strings. Okay. It's also worth noting that we start with an empty stack. Yeah, we start with an empty stack. So we're given a target list, which is the numbers and positions we want to create. We're given a number, which is the largest number in the list of integers that we want to populate the stack with, called the stream. So we are to populate a list called the stack with the elements in the target list. So we can do push and pop. Over here. This actually does seem like a pretty complicated program, so it might take a while for us to do. So the target string is just like, or I guess the instruction list. So int lists in we'll just call it the instruct list. So this is an empty list and we're supposed to put a bunch of strings in there, so push and pop. So that's the first thing. The second thing is that we've got our stack. So stack is equal to an empty list as well. And then we've got our stream. So the stream, we can also initialize the stream as an empty list. We're eventually going to create we're going to populate the stream list over here, and then use it to populate the stack. This is the stack that will have the same elements as the target list and the stream. This is the list with which we will populate the stack list. Okay, and this, I guess we will do this operation populates the stream. So it's going to be stream for I in every time I do like for I in range, I always get a little bit apprehensive, because I know that if we're going to be working with really large values of n, this can really slow down our timing. So for I in range, start at 1 and stop at n plus 1. Or sample n, well, yeah, n plus 1, because n is defined over here. So stream.append I. And just for fun, just to make sure that this worked properly, we'll start here, just print it out. Print stream. Okay. And we'll run it. Nope. Missing one required positional argument n. Oh, okay. So it's sample list and sample n. One, two, three. Okay, so n equals 3 means that stream should have 1, 2, 3. And I guess that means it worked properly. So we did populate the stream properly. We can move on. So the next step is Anarchist says the real problem are the nested ranges. So yeah, like 1,000,000 items is okay, and 1,000,000 items to the power of 2, not so much. Yeah, I mean, I guess we'll come to that problem. We'll come to that bridge when we get there. So the first thing we want to do is we just want to build like a working program. Anarchist, and 1 million to the 1 millionth power to the power of 2 is a really bad time. The Turnip, hello, nice to see you here. Hope you're having a good time. We're doing some elite coding over here. So we're dealing with a memory stack. Well, something that's kind of like a memory stack. Initially, the stack S is empty. The last element is the top of the stack. Okay. So I guess the first thing we want to do is... So our target is 1 and 3. We want to come up with some sort of conditionals that check to see if our thing is valid, right? We also, I guess the other thing we want to do is we want to set up our functions inside of here. So build array. So build array is a function. Can we put other functions inside of this function? Or maybe we don't need to actually create the functions. We just need to remember that these are kind of like the functions we're supposed to be doing. So the stream and the stack. We populate the stream, and then I guess the first check if the target is reached. So if stack is equal to what was it called? It was called like list target. So if stack is equal to target, then return instruct list. So here's our first check. Check if the target is reached. This is the stack quest. Yeah. We should be able to define other functions in the class and use them. Okay, so build array. So class solution, build array, and then we can also put like a push function and a pop function, but maybe we don't need to necessarily do that. Maybe we just need to include it in our if our if else instructions and our loops and stuff. You can even define functions inside of function to use locally. Yeah. I mean the thing about these two functions, push and pop, they're not very sophisticated functions. They're just basically one instruction. Because we see here that the push instruction just appends to the end of the list, the stack list, I guess. Appends to the end of the stack list the current number in the stream. And pop just removes the last element in the stack list. So we don't really need to define functions for those because the instructions are so... well, it's just one instruction. Okay, so check if the target is reached. So that's the first check. The second check would be check if the wasn't saying that they were needed here, just noting that Python is nicely flexible here. Yeah. So if the target is not reached, then we need to either pop or push. Check if we need to pop or push. So how do we check that? So in this case, we need to create our sample list, which is the element 1 and the element 3. So the n size is the largest. Well, okay. So we know that the first time we push, we'll push the number 1. We'll push the number 1, the next time is number 2, the next time after that is number 3. So we know the instructions here. The instructions are going to be push to put 1 on the stack, and then push to put 2 on the stack, and then pop to pop 2 off the stack, and then push to put 3 on the stack. I guess the other thing we need to do is we need to define the position of the stream, right? So we got the stream numbers. We also need to have like a stream position. This is the index position of the stream. Stream index. Stream index equals 0 because the index starts at 0. And then after each time we... Oh, the other thing we need to do is, yeah, we need to specify that each time we push, the stream index has to increase by 1. Okay, so let's define a couple of other functions up here. Oh, but this is inside of build array. Okay, we'll do this. We'll see if we can do this within the next hour or so. I'm not sure if we can do it in 60 minutes. Well, I guess we'll see. Okay, it seems like we don't need the whole stream around. We can just have the current value and increment it. We don't need the whole stream value. We can just you can just have the current value and increment it. Let's see, class solution. I think, so the build array function is in here. We can start it when they can push it. We can push it and it goes to 2, etc. We can just have the current value and increment it. Like, we can start it at 1 and we can push it goes to 2. I mean, yeah, I guess we could also do it that way, because that means we don't necessarily need to have a list. So the stream starts at 1, but we also need to remember we also need to remember that the stream caps out at a certain value, which is the n value over here. I mean, we could... Yeah, stream value increments. So we can start at 1. Say we start at 1 and we don't want to have like a list, right? This is the value with which we will populate the stack list. So stream equals 1. We don't need to populate it in this case. And in that case, we don't need an index value for the stream either. Okay, check to see if the target is reached. If stack equals target, then return the instruction list. Check to see if we need to pop or push. If now, how do we conduct this check though? We're trying to create this list 1 and 3. We know the instructions that we need to do. The question is, how do we construct a program which if or else like conditions do we need to set here? I guess the first thing would be if like the length of target. No, if the length of stack is 0, then of course we need to stack.append. Oh, I guess we can also wrap this all up in like a while true loop, like infinite loop. So while true, so stack.append stream. And then stream, if stream is not equal to n, then stream will increment by 1. So this is basically the push instruction. So after we append, we need to record the instruction. So that's going to be instruct list dot append push. Okay, Anarchist says you don't actually need to track the stack. You don't actually need to track the stack, which will speed things up. For debugging, it might be easier. Zamru says, are we guaranteed the results will be in the stack in the order that they come in the stream? We'll never get something like 132. 132. I mean, let's take a look at the instructions. Okay, you have a stream with the integers in the range 1 to n. Use the two stack operations to make the numbers in the stack from the bottom to the top equal to target. You have to follow these rules. So if the stream of the integers is not empty, pick the next integer from the stream and push it to the top of the stack. Oh, so the stream can eventually empty out. Pick the next integer from the stream and push it to the top of the stack. So this implies that the stream can empty out, and in which case we're not able to push anymore. If the stack is not empty, pop the integer at the top of the stack. So popping the integer at the top of the stack doesn't do anything to the stream. If at any moment the elements in the stack are equal to target, do not read integers from the stream and do not do more operations. So return the stack operations needed to build target, following the mentioned rules. There are multiple valid answers to return any of them. So 1, 3. So Zamru asked the question whether or not they would give you something like 1, 3, 2. And I don't think in the examples this doesn't happen. So target length is from 1 to 100. The target length would be 1 to 100, and the end value is from 1 to 100. Target is strictly increasing. Okay, so target is strictly increasing means that Zamru's question, the answer to Zamru's question is that there will never be backwards. There will never be like elements in the list that are smaller than the previous one. Right. Okay, let's continue. So append to the thing, push. So the next one is else if. So if stack equals target, return instruction list. If the length of the stack is equal to 0, then stack.append. So that's the push instruction. Else if so I guess this would be a check. So check if we have the correct first value. I mean, there's got to be a better way to do this. We can't check these values one by one because there could be like 50 values. There could be 100 values. So this ends this. We also have to make sure that this ends the current loop. So append push and then continue. So check if we have the correct value. So if the length of the stack is 0, obviously we need to push, but otherwise we need to check the target list and the stack list and look for something. But what is that something? So check if the numbers match. So does element 1 in the sample or in the target match element 1 in the target? And if so, keep on going until it doesn't match. I guess we need to check the length. Maybe compare the lengths of the length of the stack and the length of the target. Because if they're the same, then we have a then we have a problem. Or maybe we don't have a problem. So say we've got 1, and that matches this element here. So 1 and 1, that's a match. And then we go to 3 and like out of range. That we can't do it like that. So I guess another question we can ask is, under what circumstances do we pop? So we've got one condition under which we push. So if, you know, if the stack is empty, of course we have to push. I guess we would do like comparison. Compare the second element, and if the second element isn't the same, then we need to pop. Check if we have the correct number of elements. Number of elements. Okay, I think you're misunderstanding the problem. You don't only push if the stack is empty. Oh no, we don't only push if the stack is empty, but we need to push if the stack is empty. I'm just thinking about what the condition would be to pop. So we pop if we compare the elements in the list, and if HyperSC, hello, nice to see you here. You're the real frog. Well, I mean, I'm just trying to do some coding on stream. If that makes me a frog, then I guess so. So if the numbers don't match, we have to pop. Forget about the coding? Well, I mean, we're here to learn coding right now. That's the goal of the stream. I don't know. I gotta stick to my schedule, HyperSC. I'm afraid I can't help you. Check if they have the correct values in our indexes. Okay, so check if we have the correct values in the index. I guess we can do the comparisons, right? Compare element 1 with element 1. Although I guess we would also have to do like current checked element or like current element. So check the elements in order. So the current element is 0, so we start at 0, and then we'll increment after we confirm that the elements are the same. Now, how do we increment this? How do we implement this? Check to see if we would need to pop or push. This isn't, this is just if the stack has no items, push. Check to see if we have the correct value in the indexes. So if target element current element is equal to stack current element, then do something. Then current element is incremented by 1. But eventually this will come to a place where it's like index out of range. So I don't know if this is going to work out as well as we'd like to. And this is already starting to get a bit complicated looking. Okay, let me start brainstorming a little bit over here. So the program needs to decide whether it pushes or pops the element. Okay, so Xamaru says to set it explicitly, push and pop undo each other. If we push an element, then immediately pop it, we get exactly what we had before. Does it help us somehow? So when you do push, the current stream value is pushed. When you pop, the last stack element is removed. So they do kind of like undo each other, but the next time you push, the next current stream value is pushed, right? So in this case, the current stream value could be 1, and then the next time you push, then it would be 2. So if you do these in order, so 1 gets added, then 1 gets removed, and then 2 gets added. Okay, Anarchist says, hint, you need to decide if you push. You never need to decide if you push. You never need to decide if you push. You always have to push to get an item off the stream, the only choice is popping. Okay, so push and pop is a way for us to consume stream elements without keeping them. Yeah. So let's think about what Anarchist said. So Anarchist said, you never need to decide if you push. You always have to push to get an item off the stream. The only choice is popping. Okay, so if the stack has no elements, I guess it would be if something something pop, otherwise push. So if stack equals target, then return the instruction list. Otherwise, if something, then push, right? No, if something, then pop. Then stack.pop. Stack.pop, and then instruct list dot append pop, and then continue. So otherwise, so if else. Stack.append the thing in the stream, and if stream is not equal to n, then increment the stream, and then instruction list.append push, and then continue to the next one. Okay, so let's see. Anarchist says, I structured mine for I in range. For I in range, loop through the numbers in the stream. The first element is an unconditional push. Unconditional push, I didn't store the stack at all. You didn't store the stack at all. Interesting. For I in range, I to n plus 1. So it's going to run through a maximum number equal to the number of elements in the stream, right? That makes sense. Unconditional push. You didn't store the stack at all. I guess you don't, maybe you don't need to store the stack, but you do need to store the instructions. You do need to store the instructions because you need to return them eventually. Yeah, the stream of the integers is n 1 to n, it specifies. Yeah. Okay, so if the stack has no items, not this one. So if something, then pop. Otherwise, push. Okay, what is this IDE? It's not really an IDE, this is just the nanotext editor. Thank you very much, Colizador. Thank you very much for following on Twitch. Thank you. I guess in this case we don't really need to keep track of the... We don't really need to worry about the stream running out of numbers. So stream increments, and then the next thing is going to be a different value. So we just need to think about what the condition would be for the popping. Because their sample list is 1 and 3. So it wouldn't be the length of the list, the length of the stack. And Anarchist said that they didn't store the stack. So if we don't really care about the value in the stack, we're just comparing against the target list. For I in range, if I is the same, if sample list and target list, I mean target list is a stack. When do we pop stuff off the stack? Okay, so the default action in each iteration of the loop is to push an item to the stack, unless something. So we always push to the stack unless the target unless the previous element plus 1. Unless we don't. Yeah, that must be it. Children, hello, nice to see you here. Unless the previous iteration number plus 1 is not equal to... Unless the previous iteration plus 1 is not equal to the... Unless you found all the targets, then you return. Unless you found all the targets. But how do we test? Unless you found all the targets. Okay. So unless the next... We set up the current index before, didn't we? Yeah, we did. We set up the current index in one of the variables. Find all the targets. So the check to find the targets, we check to see if we've got those numbers. So let's think about it in the context of checking for target elements. So in our first case, we've got 1 and 3. So these are our targets. Check the stack for the first target. Check the target for the first target. If it exists, then check for the next target. If it doesn't exist, push. No, if it doesn't exist, If it does exist, then check for the next target. If it doesn't exist, we either have to push or we need to pop. Okay, I could have also structured mine as a loop through targets. That might have been simpler, I just didn't think about it that way at first. I mean, there are so many different ways to solve these problems that, although, you know, I say there are so many different ways to solve these problems, we're having a problem coming up with even one. But there are other solutions to these problems. Check the stack for the first target. If it exists, then check for the next target. If it also exists, I mean, eventually this goes to like if all the targets exist. If all the targets exist, then return the list and finish. That's checking for the target elements. I mean, we talked about checking the elements at the index. But let's think a little bit more about what Anarchist was talking about, right? So the default action in each iteration of the loop is to push net into the stack, unless... So what could the answer be? Unless the next... element in the target list is larger than the current value of the stack. So I guess you would check to see if the next element in the target list is larger than the current element of the stack, which would make sense. So if you got 1 in your list, and then the next and in your current stack you've got the number 2. Okay, Xamarin says, I think unless is the wrong way to think here. It's an and. We're always pushing, and sometimes we're popping off what we just pushed. And sometimes we're popping off what we just pushed. Okay, yeah, let me think about that. So the default action is in each iteration of the loop is to push an item to the stack, and then if the next element in the target list is larger than the current value of the stack, then we pop. We pop what we just pushed. So that means that our default action for the first loop would be 1. And then if the next element of the stack is larger than the current value of the stack, so in that case it would jump from 1 to 3. Then we pop what we just pushed. I mean, it would pop immediately then, because we go from 1 to 2. This is what I was trying to say. Oh, yeah, thanks for trying to put it in more than one way to help me out. Okay, I think we're onto something here. So we always push. We always push. And then we check to see if the next element in the target list is larger than the current value of the stack. So like I plus, I guess we would have to do this as like a for loop instead of a while loop. So we would go like, not while true, but like for I in range. Starting at 1 and then n plus 1. So I guess in this case we don't really need to keep track of the stack. Yeah, we don't need to keep track of the stack. We'll just delete this stack list here. So they populate the stack list. The stack list is the stream, and the stream starts at 1. Okay, check the elements in order. I don't know where we're going to be doing this. You can use it as a for loop either over the targets and over the stream. You also need to track the other one. Yeah, we also need to track the stream. So let's see, just run the loop a number of times equal to n. But we always check if the stack is equal to the target. Actually, I guess we don't really need to, we don't have a stack anymore. I guess in this case we would make sure that the current element, if current element equals like found numbers, stack elements. Stack elements equals 0, and we're checking if the stack elements are equal to the length of the target list. So if stack elements equals length of target, then return instruction list, and the thing ends. If something, then pop. No, it's if something, it's always push. So always push. So this is the push thing. Let's copy that. So stack.append stack.append stream increments. Stream increments. Instruction list.append push. Don't continue. This is all part of the same thing. And then we do another check. So always push. And if the next element, Flopper 48 HP, hello, nice to see you here. We're just doing some coding right now. We're doing this problem from LeetCode. Hope you're having a good day. Okay, and if the next element in the target, you don't have to stream through anymore. You don't have a stream though anymore. That's what the for loop is, the items in the stream. That's what the for loop is for the items in the stream. You don't have a stream. Oh, we don't have a stream anymore. The items in the stream are... Okay, okay. That does make sense. So just stack.append I, right? Stack.append I. Yeah, we can just use I in this case. Okay, so we get rid of that. So we don't need a stream variable either. So let's see. So in our for loop, we do our check to see if the number of elements in the stack elements and the length of the target is the same, and if it's so, then we return the thing. Although maybe this is not... Is this the best way to do it? Check if our target length matches our elements. So if stack elements equals like the target, then return the instruction list. Probably not. You can leave that for now. It will work. You can optimize out the stack entirely. Okay, so stack elements. Stack.append I. Instruction list dot append push, and we need to do like stack elements increment by 1. Okay, and if the next loop, and if the next element in the target is more than the next iteration number, then we pop, right? You don't need stack elements, you can just use length of the stack. I mean, we're not keeping track of the stack anymore, right? We don't have a stack list anymore. So we just have stack elements. So always push. Okay, so if... Ooh, let's... So stack elements. Check the elements. Well, this is keeping track of the elements. Keep track of the elements in the stack. And we also need to keep track of our position. Keep track of the position to check in the target. So that's going to be target position. So the first target position is 0. And we need to increment this with each thing in the... A stack is helpful for debugging. You got stacked out append, so... Oh, so I assumed you were keeping it. I guess we're not keeping track of, So always push. So yeah, our stack list disappeared. So we append push. We append push. Stack elements gets incremented by 1. I mean, I guess keeping track of the stack would be good for debugging. That's true. Okay, so we need to keep track of stack elements. We need to keep track of the target position. So I guess the last... Target position always increments by 1. So the last instruction will be to iterate, or like, yeah, what is the word? Increment. Increment the target position. So it would be target position plus equals 1. So the pop check. So the pop check is if the next element in the target is more than the next iteration number. So if I is less than what's the check again? So I starts off as 1, and the target position starts off at 0. So it's like target, the value at target position. So put target position 0 in our example is 1. So if I is less than the target value at target position index, then we need to do the pop. So instruct list dot append pop. And we need to decrement the elements. So stack elements by 1. And then the last step is to always increment the target position value by 1. Okay, I think we've got all of our parts for the program. I don't know if this is going to work or not. Well, here goes nothing. Why are we always incrementing the target position? Why are we always incrementing the target position? Because doesn't the target position have to match up with so the target position, we're comparing element 0 and then we're comparing element 1 and then it doesn't always increase. So when does it increase and when does it not increase? So always push. Always push if the next element in the target is more than the next iteration number. Then pop. Increment the target position value. So if Captain, hello, nice to see you here. We're currently doing this problem from LeetCode. Trying to figure out how to deal with the memory stack. Quote-unquote memory stack. So increment the position value. I guess we don't need to increment the position value if so the target's position and the current, I guess we also need to keep track of our current position. Keep track of our current position in the stack. Current position equals 0. But how does this come into play? So the target position is 0, then it becomes 1. So if we're keeping track of the current position for our stack list, when do we increment it? So we increment it if we pushed but we didn't pop. This is so confusing. Okay, so always push stack elements +1 and then current position +1. But if we pop, then stack elements is -1 and current position is -1. Current position is -1. So increment the target position value. This happens if the current position is equal to the target position. But the target position starts at... The target position increments if the current position is less. If the current position is less than the target position. If the current position but they're both 0. Okay, Erica says, why add and then a subtract? Just put it in an else. Just put it in an else. Okay, so percent should be and. Percent should be and. I'm sorry, can you specify a line number? Okay, compare target and stack element by element. If not the same, pop the stack and get the next integer from the target. If the length of the target and the length of the stack is the same, and element by element is the same, then all done. Okay, plus stack elements is always equal to current position, so you don't need both. LeetCode, don't do this to yourself. So stack elements is always equal to current position. Okay, so I guess we don't need to keep track of this, it's redundant. So stack elements is our current position. So the target position. So when do we need to increment our target position? We need to increment our target position if the current position is not equal. So it would be the, what was it, stack elements? So it's like if stack elements not equal to target position, then target position increments. Okay, increment target position when you correctly find a target value. So if we correctly find the target value, this is a comparison, right? So it's the same comparison that we do for pop. So if the stack elements if the current iteration number is less than the target at the target position. Okay, once you've got a correct value in the current spot in our stack, we can leave it and start considering the next element in the target. So the current position, well, I guess we're not keeping track of current position anymore. So we can get rid of this, we can also get rid of this. And we're just keeping track of the stack elements. If I is greater than, no, if I is less than the target, for the target position, the next target position, not the current one. So the target position plus 1. But that'll never be, right? No, I think this is, Okay, else if I is less than the target position, which might be better, just if I is equal to target position, increment, otherwise pop. I mean, I need to make sure it's the flow makes sense in my head. So if the what's at the stack elements if it's not equal to the target position. So stack element starts at 0, and then stack elements increases by 1. If it's not equal to the target position, then the target position is going to increment. Okay, let's just see what happens if we try to run this. Curious, why Nano though? I use Nano because it's the easiest text editor I can use, and I don't need a lot of fancy tools. I just need to write my code, and I don't need any macros either. So I just want to keep it as simple as possible. We shouldn't be comparing to target position directly. That's an index, not an actual value. So target position. So like target. I mean, I don't think we want to compare it against the value at the target index though. Unless we're not comparing the stack elements. So stack elements being the number of items in the stack. Because this would never go through. Let me just give it a shot and see what happens. None. What? None. So they returned none. Okay, so for I in range, check for the target length matches our elements. Okay. I'm gonna put another 15 minutes on the clock, and if I can't get this done in 15 minutes, I'm gonna have to call it, because I can't go for super long. You don't have a return statement. True. So for I in range, return instruction list. So we're modifying instruction lists throughout. So always push. Append push. Instruction list out append push. Oh, I guess... Yeah, this doesn't work. Stack elements equals length of the target. So if stack elements equals the length of the target, so in this case the length of the target is 2. So the stack elements never becomes 2. That's kind of funny. I just changed it to break and unconditionally return at the end of the function. Easier to debug. I guess we can also just print out, like, some messages in the inside of here, right? Print we pushed, and then here print out we popped. We're running this with build array sample list sample n. Stack will become 1 and then 1 2 and then 1 and then 1 3. Having functions that only sometimes return or loops that only sometimes end makes things hard. Better just structure things differently. We pushed, we popped, we pushed, we pushed, we pushed, we popped, we pushed. So 1 2 1 2 1 and then 3. And then I guess oh, because this happens at the beginning, it didn't return. It didn't return the final list. So maybe if we add this to the end, if stack elements equals length target, then return instruction list. We'll put this at the end of the loop. Check if our target length matches our elements. it, and we'll copy this. Okay, and then we'll remove it from up here. Push, pop, push, 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 pop, push. Okay. So I think this is working. We'll try it with a couple of other values as well to see if it works for those other values. So target 1, 2, N4. So output is push and push. Okay, so 1, 2, and N4. Looks perfect. It took a really long time to get here. We pushed, push, push. Okay, so that worked. So the 2 examples, no, we've got 3 examples. So the example 2 is 1, 2, 3, and 3, so that's going to be push, push, push. Yeah, first try, first try. Okay. We pushed, push, push, push. All right, I think we're ready to try it out. So this was called stack something, stack operations. This is a bit long, but anyways, we'll see if it works. Okay, so I think we need to get rid of these print statements because they kind of get in the way, especially of speed. All right, and then we'll run. Accepted. Okay. So accepted. Push, pop, pop, push. Okay, great. And we'll try the cloud submission. Does this take too long? It works. Beats 100%. Wow. I didn't even intend on that. Okay. I'm not really completely... I don't completely understand what the code does, but we got there eventually. We'll copy this stuff here, and then we'll put it in our walkthrough. I guess I'd understand a lot better if I did more challenges that had these kind of elements. Although it seems kind of intimidating to try that. Okay. Man, that was... Well, this is what we're here for. We're here to challenge ourselves. Error loading page. What happened? Stacks are useful for data structures. Stacks are useful data structures. They're a good thing to understand for sure. I mean, they're definitely something I need to understand to better understand memory structures, because memory structures are kind of similar, like a last in first out kind of principle. Okay, so well, let's take a look at who else might be streaming right now. So infosecstreams.com is a great list that you can look at. if you want to find other people who do cybersecurity and tech stuff. And right now, I'm pretty sure that the list is broken. The list usually shows the people who are online with a little green dot, but it doesn't seem to be showing that these days. But if you take a look at the list, the people who streamed the most, the most number of hours, are up at the top. So I guess I am up near the top in Urasakai, and Panako Panko, and Theo, B Theo, is also at the top of this list. Who else is streaming right now? So it doesn't show who's online. Let me take a look. And if anybody has any suggestions on who to raid on Twitch, let me know. You know, somebody suggested this one streamer named May Saka. It looks like they're doing software and game development. Let's take a look at what they're doing. Deja vu? Time traveler, hello. Do you often experience deja vu as a time traveler? So May Saka, somebody suggested this person to us. I wonder if they're doing tech-related stuff right now. Oh, we gotta... Okay, I stream variety software development, anything from engines to operating systems. Occasionally I will do game dev or maybe even play games, or reverse engineer stuff, or do electronics. Are you watching? Stare. Are you reading this? More stare. Okay, so apparently this person ooh. This looks like some serious some serious tech stuff for sure. She's special. Okay, let's raid into her channel. Okay, we'll be raiding in just a little bit, digging into the Motorola 68K IC creating emulator. Okay, this looks like a pretty special stream. But what are we doing next? Next time, so today's Coding Sunday, we're also going to be doing some co-working. We're going to be learning some C programming with our course, and that's going to be on Tuesday about the same time that we're doing it tonight. So everybody stay tuned for that. I hope everybody has a great start to their week. When you arrive at May Saka's channel, if you could give our special message over here, OS Frog, Hip Hop Hack, OS Frog, I would really appreciate it. See you Tuesday, Agent 57. And yeah, please be nice to May Saka and give the raid message. Alright, we'll be here in a couple days, ready to raid in 5, 4, 3, 2, 1. HackerFrogs out.